In this video, I will show you how to work with logarithms in order to answer questions about exponential models. You may recall that logarithms are inverses for exponential functions. If y equals 10 to the x, then log base 10 of y is equal to x. In other words, log functions output the exponents in an exponential calculation. Because of this, logarithms give us an important tool for doing calculations with exponential models. There are two log rules that will be important for us. The first rule shows that log functions turn products into sums. The second rule shows that logs convert exponents into a product. For example, let's say we wanted to compute the log of 100 times 1000. Using the first rule, we can write this as the log of 100 plus the log of 1000. I'm also going to rewrite 100 as 10 squared and 1000 is 10 cubed. The log of 10 to the second is going to be 2 times the log of 10, and the log of 10 to the third will be 3 times log of 10 as well. Log base 10 of 10 is equal to 1, and so I get that this is equal to 2 plus 3, or 5. In other words, we can see that 100 times 1000 is equal to 100,000, which we can write as 10 to the fifth. The log of 10 to the fifth is equal to 5. We can use logarithms to help us with the following question. Suppose you consume 200 milligrams of caffeine, say from drinking 2 strong cups of coffee. How long will it be before your caffeine level is down to 20 milligrams? In an earlier problem, we learned that the typical body metabolizes caffeine at a rate of 17% per hour. Using this, we get the following equation for caffeine in the body. S is equal to 200 times 1 minus 0.17 to the n, where n represents the number of hours after the caffeine was consumed. We want to solve for what value of s gives us s is equal to 20. I know that logs help me undo the exponential portion of this equation, but first I want to isolate that piece. I divide both sides by 200. Then I can take the log of each side. Using the second law of logarithms, I can rewrite this as n times the log of 1 minus 0.17 is equal to the log of 1 over 10. This now allows me to solve for n. Calculating this value, I get that n is approximately 12. That is, it takes 12 hours after drinking the 200 milligrams of caffeine for my caffeine level to drop to 20 milligrams.